Alrighty, good people. So we are ready to tackle examples 3 and 4, and maybe even example 5. I want to remind you that when we were taking derivatives, whenever we encountered radicals like square root, like cube root, like fourth root, it was imperative, it was very important that we rewrote them first and then took the derivative. Same thing with fractional rational function situations like this. Whenever my power function was in the denominator, it was important that I rewrote it first in order to take the derivative. Well, the same thing with antiderivatives. And so when I look at letter A, for example, 3 here, excuse me, it might be helpful if we rewrite this as, well, first of all, the 5 I'm going to pull to the front. If I rewrite the square root of x as x to the 1/2 power. Now remember, just because I write a 1/2 power doesn't mean this is the derivative. This is just another way to write square root of x. So this is still not the antiderivative. I need to perform the reverse power rule in order to find the antiderivative. So what is the reverse power rule? The reverse power rule says add 1 to the exponent. So that's going to give me 3/2, right? If you add 1/2 plus 1, that's 1.5, which is 3/2. And I'm going to divide it by 3/2. Now that looks a little bit funky, but I'm going to stick with it. And then add the constant. Well, whenever you divide by a fraction, it's the same thing as multiplying by its reciprocal. So this is really 5 times 2/3 x to the 3/2 plus c. And if I combine these two with multiplication, I'm going to get 10/3 x to the 3/2 plus c. Or I guess I could write it as 10/3 the square root of x to the third plus c. Both of these are correct, and both of these would be the antiderivative of 5 squared of x. All right, so what do we need to remember here? The idea that when I add 1 to the exponent and I divide by the new exponent, if my exponent is a fraction, I can just take the reciprocal and multiply it. So in the next example, I'm going to combine these two lines into one. So when I look at letter B here, I'm going to pull out the 2. I'm going to rewrite this radical as x to the 1/3 dx. I don't know why it looks like y 1/3. There you go. And now I'm going to do the rule. So I have the 2 constant times. I'm going to take x, I'm going to add 1 to the exponent. So if I add 1 to the exponent, that's going to give me 4/3. And I'm going to divide by 4/3. But remember, dividing by 4/3 is the same thing as multiplying by its reciprocal 3/4 plus c. This would be the antiderivative that we're looking for. If we clean it up a little bit, I can reduce the 2 with a 2 here, and I'll be left with 3/2 x to the 4/3 plus c. Or I could also write it as 3/2 cube root of x to the 4th plus c. Either one of these is correct. That would give me the derivative. The derivative of either one of these is 2 times the cube root of x. All right, so be careful when you have fractional exponents. I think you understand the nature of this. When I look at letter C, again, I'm going to take out the 2/5. Again, I'm going to rewrite this as x to the 1/4. And then I'm going to do the reverse power rule. The reverse power rule says take my exponent and add 1 to it. So that's going to give me 5/4. And I'm going to divide by 5/4, except that's the same thing as multiplying by 4/5 plus c. When I put it together, there should be a multiplication symbol here. When I multiply these two together, I'll get 8/25 x to the 5/4 plus c, and that would be my answer. Or 8/25 the 4th root of x to the 5th plus c. Both of those are my antiderivative. The question then becomes, well, which one do I write? It depends. Am I doing a multiple choice question? Then I'm looking to see what are the choices, how are the choices written in fractional exponent or in radical form. If it's a free response, then I can write it either or, doesn't matter which way I leave it as. So when I'm dealing with radicals, when I'm dealing with roots, whether it's cube root, fourth root, square root, I need to change it to fraction, and then I can apply the rule. Now, example 4 says, well, what if we don't have roots, but we have rational functions like 1 over x to the third? I still need to rewrite this. I cannot do antiderivatives in the denominator just like I couldn't do regular derivatives in the denominator. So I'm going to need to rewrite this. This is the integral or the antiderivative of x to the negative 3. And now I can do that reverse power rule. Add 1 to the exponent, divide by the new exponent, plus c. Or if I want to leave it with the exponent to be positive, that means this whole thing needs to flip down, and I'm left with negative 2, 1 over negative 2x squared plus c. This is correct, and this is correct. Most of the time, they will not give you a multiple choice option that has a negative in an exponent that's a negative. They will want you to simplify it down to this level. So far, so good. I feel like this is doable. When I do letter B, there's a constant, 2/3. So I'm going to pull that out, 2/3. And I'm going to rewrite what's left, which would be 1 over x squared. That's x to the negative 2. And now let's do the reverse power rule. Add 1 to the exponent, divide by the new exponent, plus c. So that's going to be either negative 2/3, because if I multiply negative 2 times 3, that's negative 2/3, x to the negative 1 plus c, or negative 2 over 3x plus c. Right? The negative 1 exponent tells me that it's going to flip. It's going to take the reciprocal down to the denominator, and it's going to end up next to multiply times the 3. And that's letter B. And then finally, letter C. Again, let's pull out that constant. Let's rewrite the leftover x to the negative 4 dx. And now we can do the reverse power rule. Add 1 to the exponent, divide by the new exponent. And when you do that, oh, and don't forget to plus c. Excuse me, when you do that, I believe you're left with 3/5 x to the negative 3 plus c, or 3 over 5 x to the third plus c. I just put these two together, and I got negative 9 over negative 15, and I reduced it, and then I rewrote it without the negative exponent. And then finally, when we get to example 5 says, what if we mix them together? I have roots and I have fractions. Can we work on those? So let's work on these really quick. Constant, push it out. I'm left with a 1. If I push this out, I'm left with a 1. So then this is really x to the negative, because it's in the denominator, and I'm going to push it up. And then it's a root, so it's the square root, so it's x to the negative 1/2 dx. Add 1 to the exponent, divide by the new exponent. So dividing by 1/2, that's the same thing as multiplying by 2 over 1 plus c. So that's going to leave me with 4x to the 1/2 plus c, or 4 square root of x plus c. And then check. If you take the derivative of this, does it get you back to the integrand that we started with in example A? The rest kind of flow through. Let's do letter C. I'm going to skip B just for time's sake. Let's do letter C. We'll finish with that. There's a constant, negative 1/3. So negative 1/3 on the outside. And then this is in the denominator. I want to flip it up. So that's going to be x to the negative 1/5 dx. So I have negative 1/3 times. I'm going to add 1 to the exponent. So that's going to give me 4/5 divided by 4/5, which is the same thing as multiplying by 5/4 plus c. So this is negative 5/12 x to the 4/5 plus c, or negative 5/12. Maybe I should do it over here on the side. Negative 5/12 the fifth root of x to the fourth plus c. I'm putting both of these versions because, again, if you are doing this on a free response, you can stop here. You're good. If you're looking for a multiple choice, then they will probably have it in radical form. And just like that, we did a bunch of antiderivatives just by using the reverse of the power rule. Just like in differentiation, when we take derivatives, you cannot take the derivative of a radical without rewriting it. That's what we did in example 3. And just like in derivatives, you can't take the antiderivative of something that's in the denominator. You have to take the reciprocal and introduce a negative exponent, which is what we did on example 4. We continue to do those same and apply those same types of rules. We'll come back in the last video and kind of wrap it up.